take them down and take them down and take them down, take them down, take them down and take them down and take them down. As you look, the whole room explode down and pick the cue, pick the cue. As you look, the whole room explode down and.
So, I was just trying to give a quick introduction to what we are going to do, and I'm going to talk a little bit about geeks and music and how it seems to be a love and hate relationship. And obviously there's a lot of love going on, but somehow it doesn't really connect. So, what's that? My name is Jan. I'm Halfbyte on Twitter and GitHub and whatnot. I'm a freelance web developer, and I do things like creating like JavaScript web applications, but I also try to write books. The single page app.com is the domain, and this is the first book I'm writing. I also got buttons like this one here. If you want some, you can get them later on at the party or after this talk. And I really would like you to check out the singlepageapp.com. I should have written the URL on here somewhere. So geeks and music. So how many of you in this room are playing an instrument? Okay, a few hands. So in my surroundings and in the field I'm working in, there are a lot of musicians that are also programmers, and I find that kind of interesting because I think it has to do something with music at times being very mathematical, and also probably something with music being a very good way of kind of balancing stuff. So if you're having a hard time doing your day job, and being a programmer is often a very hard job, playing an instrument can kind of relax you and bring you back to earth and stuff like that. So there's a lot of stuff like that going on, I guess. But it seems to me like there are many programmers who are also musicians in some ways. My sad story is that I kind of quit doing stuff with musical instruments at the age of, 10 maybe, when I left elementary school. So we played flute at the elementary school, and I kind of hated it all the time. And I never properly learned to play an instrument. And since I love music and I love creating music, I had to compensate that somehow. And during the 90s, I used a program that looks like this. Does anybody recognize what this is? Okay. I see a hand. That's great. So this is ProTracker. It's a software that was running on Amiga computers at the time. There are trackers for PCs and stuff, and for other systems. There were trackers on the C64, which is my first computer. And if you look at it, it looks really technical. So it doesn't look musical at all. There are these huge columns of numbers, and there are F's and G's and C's in there, so it has to do something with music. But then there's also like C to A, and what does it all mean? And it's actually a little bit like programming. So it's just a pattern that runs through, and you can also do some commands to change volume and pitch and stuff like that. So it's a little bit like programming. It's by no means Turing complete, but it's a fun way to do music, and it was my approach to music, really. And I did a lot of really bad rave and breakbeat stuff back in the days. Then I kind of got into all these graphical music environments we have now, like Cubase and Logic and stuff like Ableton Live. And I always kind of miss this direct connection. You always have to use your mouse and kind of draw bars and stuff, and it looks more musical, but it's also very, very far away from what I do normally. And so my approach to doing music is pretty much programming music instead of kind of playing on an instrument. And I think now is the time to learn how to do that, because we have the Web Audio API, and it's this amazing piece of software that is sitting in like WebKit browsers, even in mobile, so on iPhone and on Chrome 4, on Android, Android 4 in Chrome, and in Chrome and in Safari. And the Firefox guys are working on it, so it will be in Firefox. It's standardized by the W3C. And it's this amazing thing that is a node-based API, and I don't mean Node.js. I mean like, boxes connected to each other. And it has a few features I'm going to talk briefly about. So the main thing you have to do is deal with an audio context, which feels a little bit like the context, the drawing context in a canvas, for example. It manages the time base, so music is almost always based on rhythm and time and stuff like that. So you have to have some kind of timing, and it manages the hardware output. And this reminds me that there should be a cable here, and the sound guy in the back should be very nervous now. Yeah, I know. So I do have a proper sound card with me. It was just too much hassle to set it up here. So we'll be good later on. So and then after you have the audio context, you have like generators, effects, and utilities. Generators can be oscillators, like really low-level stuff like generating a tone as a sine wave or a saw wave or a square wave or anything. You can play buffers like samples, recorded instruments, whatever. And you can also generate sound on the fly in JavaScript, which I did. And it's kind of hard, but it's, software synthesis, basically. In the effects section, you have things like a delay, a convolution filter, which is an amazing tool to do like room effects and stuff like that. A filter that allows you to shape sounds, a wave shaper that can act like a distortion effect, like a guitar effect, for example. And then you have some utilities, like obviously you need something to change volume. You have a compressor, which is if you don't know that, it's an audio tool to kind of make music feel louder, basically. That's a crappy way of describing it, but probably good enough. A panner, which allows you amazingly to position sound in a 3D room. So it's thought, I think, mostly for gaming. So you can really do things like moving a sound through the room, and it will even, calculate Doppler effects and stuff like that. So really amazing stuff. And I think I will now try to do live coding. Is it really that bad? Maybe it gets better as soon as something comes out of it. We'll try. Yeah, okay. So I have this thing. And if you're coming to the Google headquarters later on, you will see a lot more of this. And I need both hands for this, so that's interesting. You can see almost nothing, like the typical. Well, that's actually a good thing. So if I click into here, you can basically see things. It's barely see things, but it's probably light enough to see what's going on here. So I made this system, and it's a thin wrapper around the web audio API, so that I don't have to do all the low-level stuff. And so I have this method that gets called like basically every 4 bars, and it has a few variables passed in here, like the WebKit audio so the audio context. So it's currently namespaced in WebKit, so you need to do WebKit audio context instead of audio context. I can Is that better? Okay. I can also make it bigger. That will help. So, yeah. You can do whatever you want with it. It's just I'm going to show you how it's used. It's just you basically you create notes at certain times, and these times are usually in the future, and you can calculate these times by using the time base that's available in the audio context. So there's this thing called current time that will basically give you the time at this very moment. Which is, it changes a lot, basically. So there's also I need to comment this. There's also a thing called audio context destination, which basically gives you a so-called audio output node, I guess, which basically gives you access to the sound card. That creates a lot of noise in this case. This is something I added, and this is just an approximation. So what I do here is for every 4 bars, I call this pattern method, and I give it like the time for the next notes in the next bar. So it could be 0, 02, 04, 06, but it could be a lot larger than this. And then there's also L, which basically gives me the length of one step. And that's probably hard to understand. So let's start with a very simple thing like so I have an oscillator, and I can actually play that. And I will use my time value because that means that I will just play it on the first note of that 4 bars. And I will switch it off then again. By the way, as I said, it's currently standardized, and these will change a lot. So this will be currently it's note on, note off. It will be start and stop, which probably makes a lot more sense because you're not totally sure if you're actually playing notes here. It could be some sound effects or something. So, and if I'm going to start this, I have a shortcut here which you can see executing that will just evaluate this whole piece of code. No, the frequency is not in here, but it's obviously not working, and the reason it's not working is because I forgot to connect it to the destination, which is O. As I said, it's note-based, and now it's doing just something. It's currently a sine wave played at 440 hertz, so that's the base frequency for all kinds of music calculations. It's the standard pitch, the musicians call that, I guess. And obviously I can change the frequency, so I could do something like frequency. And here it gets interesting because I cannot just set the frequency. That would be too easy. I need to call value on it, or use the value property, and I can set it to, let's say, an A above that. That's an octave above that. And the reason why this is, and I think I'm going to switch this off real quick. So the reason this is not a single assignment is that there are a lot of things you can do with these so-called audio params, and you can do stuff like fading it from one volume to from one value to another in a given time period and stuff like that. So you can do that with almost any parameter that's in the nodes. And I'm not going to demonstrate this for you, how to vary the pitch in time. That's kind of boring, or could be messy. I could really fuck this up and kill your ears with it. So there's also other things like playing samples. I made a. I want to make this quick so we can all go to the party. So I made a little abstraction on top of it. You can read this up on in the documents. I made a little abstraction on top of it to aid my playing here, and so this is OT0, and it does almost everything automatically now. And it just plays a sample. And there's a buffer player that allows you to basically play any sample, and to play the sample you have to load it with Ajax, and you have to set the response type to what's it called, array buffer. That's a special type that allows you to allows then the WebKit audio context to decode the sample. And so you can basically play any type of audio file you have lying around. And now the beauty of so this is basic usage of Web Audio API, and the beauty of music is that it's very mathematical. So let's do some proper programming here. So I have a for loop. Everybody knows what a for loop is. And I'm going to play a sample here, and this is why didn't I copy the whole thing? So this is kind of awkward now because it plays the yeah. That's live coding for you. So that's kind of awkward. So let's do something like. Modulo. Modulo is great for this. So let's play it at every fourth step. And so this is proper techno, right? And Modulo is great for things like this. So let's turn this into real techno stuff. Yeah. But obviously you can do interesting stuff with it, stuff like why not? Yeah. But that's kind of interesting already. It's like you can play with different things, and I could also let's turn this quickly into something completely different by just playing. This is total crap, but anyway. I'm going to, So I did another thing here, which is kind of fun. I introduced some effects, and this is just a shortcut to make it easier for me. I'll see. So reverb line is another of my abstractions, and I can now have a reverb on it. And if I now do something crazy with like the bass drum, I don't know. It's dubstep, right? And I also did some more stuff here. It's going to be basically what you're going to see at the live act. It will be more sophisticated than what I just showed you, and there will be also two very talented live musicians that will accompany me. And I almost felt like, okay, it would even work without these guys, but then again, it probably won't. So I would all of you like to join me this evening at the Google headquarters. I had a lot of fun rehearsing this. I hope I will be less nervous this evening. But I'm going to switch this off now, because if you take away the focus of the window, the web audio API starts to do crazy things. And I just a few things I wanted to mention before you throw me off the stage. I used to participate in a thing called Music Hack Days, and there are awesome events that go like a weekend of hacking on music, and they are sponsored by music companies. And there are all over the world. I haven't seen of any in this region, which is a shame. So if you know any, I'm pretty sure there are Israeli music companies. So if any one of you wants to take on this challenge and do something in this regard, I have some contacts that would be really interested in doing something here. My last Music Hack Day was just to give you an idea of how crazy the locations are, and Tel Aviv is kind of crazy for a European to be at. Is Reykjavik in Iceland, so that's a nice place to be, and Tel Aviv is a nice place to be. So why not doing something like that here? And please do me a favor and check this out if you're interested in music and coding, because I think these two things can be really, really nicely combined. And see you at Google at 18:45. There will be some more drinks, I've heard. Yeah, there will be live music, not only by us, also by other people. You've seen it in the program. And just another URL for you to check out. It's another one of my websites. And thank you for listening. Looking forward to seeing you. Thank you.